Hi guys, welcome to your Unit 5 review, Graphing Linear Equations. Alright, so I'm going to go over some examples, okay, but just kind of general information that you need to know in order for you to be successful on your test, okay? So the first thing is slope. The slope has multiple generations. That's not correct. Definitions. The first being it's the ratio in the change in y to the change in x. So when you have like 2 points, and I'll go over this in another problem as well, but you could find the slope by taking like the second y point and subtracting the first y, and then doing the same with the x values, okay? And then whatever those turn out to be, then that would be your slope. But I know that's kind of vague. I have an example set up for us to do that in a little bit. I think the easiest thing to do is use this, rise over run. Okay, it's like how far up or down am I going? And then how far to the right or to the left am I going? You can also think of it as a unit rate. So that's like dividing your y value by the x value so that the x is equal to 1. It's also how steep a line is. The variable that represents slope is the letter m. Don't ask me why, I don't know. That doesn't really make sense to me either. Now, an example. So if I have a slope of 3/4, well, let's just say that my line crosses at the origin. Okay, that doesn't always happen, right? We know that, but in this particular case, let's just pretend that it does. So to apply this slope, what I would do if it's rise over run, they're both positive, so that means like I know my line is going to look like it's going uphill when I look at it from left to right. I would rise 3, 1, 2, 3, and I would run 4. And I'm like kind of working on the side over here, so I've got to make sure that I do it correctly. Okay, so there's 3, and then I could do another one. I could go up 3, 1, 2, 3, and run 4. Something along those lines. Notice they're in a straight line, right? I followed the pattern. Okay, now, that being said, really, I could have also treated this as like -3 over -4, right? A negative divided by a negative is a positive, so it's still the same slope. But what that could tell me is that if I wanted to go this way, I could go down 3, 1, 2, 3, and to the left 4 as well. And notice that's in the same line also. Okay, so there's a little review on slope, just isolated on its own. When it comes to equations, all right, so this equation here is in slope-intercept form, right? Y equals mx plus b. Now, there's a lot of things that you could do from this. One, we can say, well, I know that my slope is 2, right? Or 2 over 1, right? Those are the same thing. And if slope is rise over run, well, there's my rise, there's my run, okay? But 2 is equal to 2 over 1. I haven't changed it at all, okay? And my y-intercept in this case is equal to 1. And so the coordinate pair, wow, I lost my train of thought there, would be 0, 1. Okay, so we could do that. The other thing that you could do is you could pull information from this or coordinate pairs by using a table. I could say, well, I'm going to insert maybe 0, 1, and 2 into this equation, and I could get ordered pairs from it. So this would be like, there's our x values, right? And we're solving for our y values. So if I plug 0 in, let's see, I didn't give myself much room. Y equals 2 times 0 plus 1. Well, anything times 0 is 0, plus 1 would be 1. So in this case, it would be equal to 1. Y equals 2 times 1 plus 1. Well, 2 times 1 is 2, plus 1, that gives us 3. All right, and then the same thing with this one, the 2. If I plug 2 in, 2 times 2 is 4, plus 1 is 5, right? All of that, I'm getting all of this information from this equation. Now, I don't have to do all of this. I certainly can, and that's helpful because look at that. I also found my y-intercept, okay? And by plotting these other points, I should be able to make the line on the graph. Now, let's see here. With this, if I have 0, 1, well, starting at my origin, I'm already at 0 for my x, so I go up 1. There's my y-intercept. My slope is 2 over 1, so from my y-intercept, I can rise 2 and run 1, rise 2, run 1. Well, here's that first point, 0, 1, and look at that. There's the second point we found. 1, 3, and then 2, 5, right? So no matter whether I used the chart or I just used the slope and the y-intercept, I was able to get that same line. All right? Okay, got a couple more things for you, and then I'll let you go. All right, with this next one, it says find the slope given the points on a line. Okay, so if I want to label this as like 0.1 and 0.2, I could use that same formula that I was talking about earlier. y2 minus y1, and then x2 minus x1. So this being said, what I would do is I would say, okay, from my second point, my y value is 10. On the first point, my y value is 2, so I have 10 minus 2 over, and then the x value from my second point is 5, and then subtracting my x value from my first point is 1, okay? And then I can solve those, so 10 minus 2 is 8, 5 minus 1 is 4. So I have a slope of 8 over 4, but I can reduce that. I could reduce that, right? 8 divided by 4 is 2. So really, our slope is 2. And then applying that to a graph, though, that means I would rise 2, run 1. Okay? Last one. In your, what was it? Unit 5, lesson 8, you were presented with problems more like this setup, where it wasn't in slope-intercept form, but we can change it into slope-intercept form to then graph the equation and everything. So as a reminder, slope-intercept form is y equals mx plus b. So with this, the first thing I notice is that, ooh, they're on the same side as each other. So I want to make sure that I move this 3x over here to the right. So to do that, I'm going to subtract 3x from both sides. So that leaves me with negative 3y, and then 3x minus 3x is 0. So those cancel, and then I have 9 minus 3x. Well, now I'm slightly closer to this format. The next thing I'm going to do is I'm going to flip those. So let's see, I have negative 3y equals negative 3x plus 9. Well, in order to get y by itself, right now I'm multiplying by negative 3, so to get rid of it or cancel that out, I'm going to divide both sides by negative 3. That cancels over here on the left, and we're left with y. And then everything on this side has to be divided by negative 3. Well, look at this. Negative 3 divided by negative 3 is positive 1. So really, like, I could put a 1 there, and then I have my x, right? But we know that we don't usually put 1 as a coefficient, so we'll talk about that in a sec. And then we have 9 divided by negative 3. Well, 9 divided by negative 3 is negative 3. So my final equation in this case would be y equals x minus 3. That is in slope-intercept form, all right? But we know it's like, how many x's do I see? I see one of them, right? So 1 is my slope, even though it's not written in there. With that, we could graph it. Sorry, and I should have had this set up. Okay, let's see. So with that, my y-intercept is this value here, -3. So on my graph, let me change my color. My y-intercept is -3, so from the origin, that means I'm going down 3. And then my slope is 1. So if I have a slope of 1, that would be rise over run of 1 over 1. So I would rise 1, run 1, rise 1, run 1, rise 1, run 1, and so on, creating the line. Okay, so hopefully this helps give you some ideas of things that you can expect on your test. And as always, if it doesn't go well, we can always do corrections, okay? So I will talk to you all soon. Let me know if you need more support. Have a great day.